Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to CIECA. Welcome to the CIECA cast. This is Fred Iantorno, Executive Director of CIECA. Today's presentation is titled New Feature in Estimating, Updating Part Types. In case you might not know, this new feature is one of many estimating features that are not available in the EMS and provides a direct solution for a series of workarounds that have been used for many years in the industry. Today's speakers are Joanna Cohen and Mike Hastings of CarPart.com. Joanna is the Interchange Project Manager at CarPart. Joanna grew up around the recycling industry and in 2005 began working for CarPart.com. She is heavily involved in the assembly, workflow, design, and data testing process for integrated CarPart Pro, which increases the use of recycled parts in the collision industry with an assembly optimized workflow. Mike Hastings is a product manager at CarPart.com. He has been developing software for the collision repair industry for most of his career. Mike has worked with CIECA on the EMS standards, VDI, and the PMP, the Parts and Materials Procurement Committees, and has helped develop and implement many of the BMS messages. Mike holds a Bachelor of Science in Mechanical Engineering from the University of Toronto. If we have time, we'll take questions at the end. You can enter your question in the tab marked questions. Okay, I will now turn this over to our presenters, Joanna Cohen and Mike Hastings.
Thank you, Fred. Good morning to everyone who's joined us today. As Fred mentioned, Mike and I work at CarPart.com. Our online parts marketplace, CarPart Pro, was developed specifically for insurance appraisers and vehicle repairers. Integrated CarPart Pro helps appraisers search for and add recycled and aftermarket parts to their estimates automatically. Using alternate parts to repair a vehicle can reduce the overall cost of a claim, but often the different data sets and different part definitions used by alternate part suppliers and collision repairers causes complications in the workflow involved in successfully getting these alternate parts back on the estimate. As we began developing integrated solutions for CarPart Pro, we found a number of workflow situations that weren't covered by the old EMS standards or even the newer BMS standards. Over the past year, the VDI Committee has been working on changes to the BMS to resolve some of the issues that were found. Today, we'll go over some of the changes in the latest BMS and how they can be used to update estimates with parts from third-party searches. Oh, Fred, I lost control. I guess I need you to move the slide. Fred, could you move the slide, please? Okay, thank you. At a high level, some of the functionality that has been added includes the ability to edit a part type using the new Vehicle Damage Estimate Change Request message, the ability to handle lines on an estimate with a quantity greater than 1 using the quoted part list, and the enhanced ability to handle alternate part assemblies, including requesting assembly labor time when it's available. First, we'll go through the business cases for each of these changes, and then we'll go through some of the technical changes. Next slide, please, Fred. The first change is the ability to edit the part type. Previous EMS and BMS standards have never allowed for the changing of a part type on an estimate line. There are some proprietary implementations out there that bypass the standards and do allow this functionality, but now this ability is available for everyone in the latest BMS release. It is an increasingly common occurrence for an estimate to be sent to a third-party parts locator where many different part types can be found. For example, many estimates are written with OE component parts and sometimes even aftermarket component parts. But searching for a lower cost alternate part could cause any of the parts on the estimate to be replaced by a part of a different type. Previous standards would have required the original estimate part to be deleted and the new replacement part to be added when the part type had to change. This caused problems with unique sequence and parts identification on any subsequent searches for the same estimate. In order to solve this problem, the quoted part list was added to the part info aggregate. The quoted part list contains the quoted part aggregate, which will list all the information available about the part being written back to the estimate, including the new part type. Now anyone writing an estimate should be able to use a third-party parts locator to find replacement parts and update them on their estimate without a manual add and delete operation. Next slide, please. The second change is the ability to write back more than one sourced part per estimate line. Every estimating system allows users to add parts like wheels to the estimate with a quantity greater than 1. Previously, third-party parts locators could not handle these cases because the standards only allowed for one quoted part to be sent back per estimate line. The workaround was either a proprietary solution or to train users not to use quantity, which was obviously not ideal. With the latest BMS release, the quoted part aggregate is contained inside a quoted part list, which allows the quoted part to be repeated as many times as necessary to fulfill the requested quantity. The supplier ref num was added to the quoted part aggregate so that each quoted part can have a separate supplier. Next slide, please. The last change I'll talk about is the addition of the assembly labor code, which enhances the ability to write back alternate part assemblies using the correct labor time. The concept of an assembly is one of the major challenges in bridging the collision repair and the recycled and aftermarket parts industries. When an estimate is written, it is often done using OEM-based data, which lists each component as a separate line item. When the estimate is sent to a third-party parts locator, which includes recycled or aftermarket parts, it is possible to find one assembly that would replace multiple component lines from the estimate. The traditional methodology for dealing with this situation is to add the assembly part as a new item and delete the component parts from the estimate. During previous implementations, we became aware that each estimating system has separate parts and labor coverage for some recycled assemblies. The assembly labor code was added as a way of communicating whether recycled assembly parts and labor is available for each component on an estimate. This is important because if a recycled assembly is being sent back to an estimate to replace multiple components, the message needs to request that the estimating system add the part using the assembly labor that is available, as opposed to the labor of a single component, which may not be as high as the entire assembly. Next slide, please. Now we'll start going through the technical changes and how you might go about doing some of these things. First up is editing the part type using the new Vehicle Damage Estimate Change Request. The Vehicle Damage Estimate Change Request is an entirely new message that was copied from the Vehicle Damage Estimate Add request. Since the goal of most of these BMS changes is to be able to change existing part types on the estimate rather than add new ones, it was felt that this message would more accurately describe the content. In this example, we'll use the quoted part aggregate to replace an OEM component part on an estimate with a recycled alternative. Next slide, please. Some general notes on this example. First, as I mentioned, we're using the Vehicle Damage Estimate Change Request. Second, the recycled part supplier information is specified in the admin info supplier aggregate. That aggregate is not shown in this example, but you can find a full sample message in the implementation guide on page 186 if you want to look at the specifics. What we will show is that the quoted part list contains the quoted part aggregate, which specifies information specific to the supplied part. In this case, the supplied part is a recycled part, so the quoted part aggregate includes the part type code, which will be set to PAL for recycled part. It also includes the recycle info aggregate and the supplier ref num, which is used as a reference to the part supplier listed in the admin info section. That's probably pretty confusing without a visual. So this is just a very high-level sample. In order to fit this onto one slide, I left out a lot of information, so please do refer back to the implementation guide for specifics. First, we have the document ID, which is used as the primary key of the estimate. This communicates back to the estimating system which estimate we are trying to update. Damage line info section. This contains information about the original damage line that was on the estimate. The line number, BMS object and UUID, which is the primary key for this part, a line status code, which indicates the action that is being requested. In this case, 2 indicates change. Then you get into part information in the part info aggregate. Part type contains the original estimate part type. Part num contains the original estimate part number. Unit part price contains the original estimate price. And here we've inserted the quoted part list, which contains the quoted part aggregate. This is where you can find the information about the part being sent back to the estimate. In this aggregate, the BMS object and UUID represent a supplier-provided unique identifier. The part number in this case would be a recycled stock number. The part type here indicates that this part is changing from the original estimate part type to a PAL, which is a recycled part. The recycle info aggregate would contain any information specific to the recycled part, including source vehicle information, part grade, supplier certification, and so on. So this is the highest level view of how this message would look. We're pretty excited about this change in the BMS, and I hope that you find it useful in your own implementation. Next slide. Next, I'll show how you can use the quoted part list to handle quantities greater than 1. This is a fairly straightforward change, especially after reviewing the last change. The only real difference here is that we'll see multiple quoted parts listed inside of the quoted part list. Next slide. This message is slightly longer because it does include multiple quoted parts, so I had to remove the document ID from the example. Just as a note, that would always be included in the message being sent back, so the estimating system always has a reference to the estimate being updated. For a full XML sample of this case, you can refer to page 196 of the implementation guide. The first section of the damage line info aggregate should be similar to the last example, containing all of the required information to identify the individual damage line on the estimate being updated. I should point out that in these examples, we are showing the BMS object UUID and not the unique sequence element. In the latest BMS, a change was made to require either the UUID or the unique sequence number of the line. The UUID is preferable because it is a globally unique identifier that can be referenced by multiple parties. So let's move down to quantity, which in this case is 2. When this estimate was originally written, the appraiser indicated that they require 2 of these parts to repair the vehicle. This is common in cases of repeating parts like wheels. In this case, you can see that the quoted part list is populated by 2 quoted part aggregates. The first indicates a recycled part that was found to fulfill one of the required parts, and then an aftermarket part that was found to fulfill the second. Each can now have its own supplier information. This is pretty straightforward. Everything we see here was included in the last example. It's just a matter of repeating the quoted part aggregate for each part that needs to be associated with this estimate line. Next slide. The last change I'll talk about today is the way that assemblies are communicated in these messages. As I mentioned earlier, the traditional way of handling an assembly being returned by a third-party search is to delete the original components that are being purchased in the assembly part and add the new line for the assembly itself. This is not necessarily changing, so I'll take the opportunity here to go over the new assembly labor code element, which should be used by the estimating system to communicate when assembly labor times are available for specific components, and by a third party writing back an assembly to communicate to the estimating system whether the part they're sending back qualifies to use that assembly labor or not. Next slide. This is a copy of the assembly labor code definition in the latest master code list document. The assembly labor code element was placed inside of the labor info aggregate, which is contained inside of the damage line info aggregate. As you can see, it is an open enum type, meaning that if the code you need to use is not listed here, you can still use it. This is a new code list, and we wanted to leave the values open to allow for feedback. Currently, the codes are as follows. Available. Available is a code that would be used on the outgoing message from the estimating system to indicate that assembly labor times are available for the component listed on this damage line. Not available. This code would be used on the outgoing message from the estimating system to indicate that assembly labor times are not available for the component listed on this damage line. And then I'll skip down to used. Used is also a code that would be sent on the outgoing message from the estimating system, which would indicate that this damage line is already using assembly labor. The codes that could be sent back to the estimating system from a third party are not requested, which would mean that the part being sent back should not use assembly labor time, but should use standard OE component labor time as usual. And requested, which would mean that the part being added is an assembly and assembly labor should be used if possible. It is hoped that these codes can be used in addition to the CIECA parts found in the line item category code to help automate the addition of parts to the estimate and remove some of the clunky manual steps currently required. Next slide. As in previous examples, this is a very high-level overview with a lot of information removed. For full XML samples, refer to page 207 of the implementation guide. This first sample is an overview of what the original estimate message may look like coming out of the estimating system. Coming out, this would be the vehicle damage estimate add request, and you can see the original damage line information for 2 parts. In each damage line info section is the labor info aggregate, which contains the assembly labor code. In the first part, the code is set to available, indicating that assembly labor is available for this component part. In the second part, the code is set to not available, meaning this component part is not associated with an assembly part. Next slide, please. This next sample is an overview of what the supplier response to that message might look like. Again, the traditional method for dealing with an assembly is to delete the component parts and add a new part to cover the assembly. First, we see the actions to delete the two parts mentioned in the original supplier message. The line status code of 3 for each of these parts indicates to delete them. Next, we add the assembly part that needs to be written back to the estimate. The line status code of 1 indicates that this is an add. The first thing you might notice here is that there is no line num in this section. In the latest release, line number was made optional, so that when adding a part, it can be left out to indicate the estimating system should choose the appropriate line number. Next, in the BMS object field, we have a UUID and a ref UUID. The UUID is a new GUID that will be generated by the supplier. The ideal case is that this will be used as the UUID in the estimating system. The ref UUID will contain the UUID of the original component part on the estimate that indicated assembly labor was available. In this example, part number 1 on the estimate had an assembly labor code of available, and so the ref UUID here should be taken from the original part number 1. This should give the estimating system a bridge to automatically find the correct assembly part to use when adding this line to the estimate. After that, we have standard information like line description, the line item category code, which contains the CIECA part code, and part info, including quoted part information on the part being supplied. Next is the labor info section, which contains the assembly labor code element. In this case, the supplier used requested, which indicates they are requesting the estimating system add this part back using the assembly labor that was indicated to be available on the original supplier message. So this case is absolutely the most complicated case we covered today. All of these cases are pretty well documented in the implementation guide, and also if anyone has any questions now, we are happy to take them. Next slide, Fred.
The question that I had that came in, I'll answer shortly, which is about the video and so forth. So I have a question here. You mentioned something about the line item category code. Can either you or Mike explain that further?
Mike, do you want to explain that, or do you want me to?
Yeah. Well, I'll take a shot at it. The line item category code basically identifies the assembly, and I think it'll basically help the estimating system be able to look up the labor time for that assembly. And I think Fred, you probably know more about this than I do, but about 5 years ago, I think there was an effort to actually put that list together, the CIECA, the line item category code. Right.
But that's why I asked, go ahead.
I think this is a really good implementation of that in the message. So it's a way that, to communicate back to the estimating system how to look up the labor times for that part.
I don't see any other questions that have come in. again, for those of you that are involved in implementing these kinds of things, there's plenty of descriptions, as Joanna and Mike have mentioned in those pages of the implementation guide. So please go on that. Okay, thank you very much for that great presentation, Joanna and Mike. Thank you, audience, for joining us, and hope that you will join us for some of our future CIECA casts. Our annual symposium will be held on September 17th through the 19th in Tampa, Florida. Visit CIECAsymposium.com. Registration is open right now. There are 12 general business sessions and 4 technical sessions. Thank you for keeping abreast of the CIECA developments. Our standards are built by volunteers from all industry segments. For those that have contributed to our standards, we thank you. If you have not been involved and would like to participate, please contact Charlie Quirt. As always, this video will be available on the CIECA webcast on the CIECA website within 48 hours. Again, thank you to Joanna and Mike, and thank you, our audience, for participating. Have a great day. Bye now.